So we are going to look at some rules for circle geometry. Let me go back, make sure I'm doing all the right ones for today. Okay, the most simple thing that you can do with some of these shapes is Pythagoras, okay? So if you see a right-angled triangle inside a circle, you should always think Pythagoras. Sometimes, I'm just going to, oh, geez, let's use a straight one. Let's make it red. There we go. All right. And then let's do another one. It should be. It is. Okay, so let's say that you're given something like this, and then they might draw like an extra line, something like that, right? What's the word we use to say that these lines form a right angle? Perpendicular. Perpendicular. Okay, so if these are perpendicular, I can, if I've got some information, how many pieces of information do I need to be able to solve? I need two, right? So if you've got two and you're asked for a third, think about Pythagoras. Anytime you're given a right angled triangle, all right? That's always something to do. If you are given something, actually, no, let's do that. I'm going to do something like this. Okay. I always spell it wrong. It's maths. Okay, if I want to find the length of chord AB, does anyone have an idea of what I should do?
Yes.
Tell me what it is.
I don't know. No, you find that.
What do you think?
You find each other.
Okay, so I'm going to do Pythagoras. So let's call this X. So which side is C? Which side is the hypotenuse? 5, right? 5 is the hypotenuse. So 5 squared equals 4 squared plus x squared. So then 5 squared minus 4 squared is x squared. What's this? 9. So x is? Okay. So x is 3. Is that the length of the chord?
No, it's 6.
Okay, the length of the chord is 6, right? Because this is, okay, so this is going to be twice as long as this, so that makes AB 6. Now, there is a word I should have used that I didn't use at the start, and that is to say that this line, let's call this CD, CD bisects AB. If I say it bisects, what does that word mean mathematically? More specific, right? It cuts it exactly in half. So it doesn't just cut it in two, it cuts it perfectly in half. So anytime you see the word bisect, or a line is called a bisector, right? That means that they're telling you the line is perfectly in half. And that's extra information you need. They won't always mark it, like you could mark it like this, and they won't always do that for you. But if they use the word bisector, or this is a perpendicular bisector, it means it's at right angles and it chops it in half perfectly. All right. So the language is going to tell you things about the drawing. They won't always label it. All right, let's have a look at something else. All right, if I have, let's get some lines. Oh, let's just make it thicker. And again, I'm going to do a line like that. All right. I know I've drawn that pretty dodgily, but I'm going to tell you that these are the same length. Okay. So these are two, what's the word for these?
Sectors.
They're not parallel, they're chords. What is the, yeah, right. This is chord AB. So if these are chords, what's the definition of a chord? That's with an H, which is why I always misspell it. I always put an H in there. What's a chord mathematically?
Yeah. Coordinate X, Y.
Say it again. Perfect. Yeah. It does not go through the center. If it goes through the center, what is it? Diameter. Okay. So if it goes through the center, it's a diameter. If it doesn't, it's a chord. If these chords are equal in length, That means that any line from the center to the chords is also going to be equal. All right. If these two are equal, so is any line you can draw from the center. If I drew these two lines, they would also be equal. All right. So if I'm going out in that direction and those are equal, that's going to give me some extra information. Blah, blah, blah. Okay. So, yep, that is helpful information. Oh, I have totally messed that up in terms of saying something actually helpful. Let me go back a second. Sorry. Oh, D. I'm very sorry. I said something very stupid there. I need to draw that way more specifically. Sorry, that's true when something special is happening. What do you think? I've just drawn it differently so that something special is happening. They're what? Okay, these are right angles. Okay, so if these are right, yeah, if I drew it better, they would be. If these are right angles, these lines are equal, okay? So if the chords are equal, that is another rule that we need to think about. That also means that if this is a point, these two sections are equal and these two sections are also equal. All right, so from this point, from this line, the front two sections are equal, so are the back two sections. These whole lines are equal, and so are these inner sections. That is going to be helpful information for us. All right, they might also give you something else in this, like a line here. What is this now?
Radius.
That is a radius, yes, because it goes from the center to the outside. But what have I made here? This is a right angle triangle. So if I needed to find things, if I knew these two lengths, I could find this with Pythagoras, right? So always look for right angle triangles.